Welcome to Cisco HyperFlex video series. This is regular cluster operations. We have just installed a cluster of 5 converged nodes, and now we will start using it. Here is our current topology and addressing of the cluster. The management of the HyperFlex cluster is mainly performed through the HyperFlex Connect and vCenter web interfaces. The HX Connect manages the storage platform, the HyperFlex servers, and also provides basic virtual machine management. As you can see in HX Connect dashboard, our cluster is healthy and has 5 converged nodes. In vCenter, we currently also have the same 5 hosts added, each with its own controller virtual machine. These are not actual user VMs, but appliances, which must run on a node in order for the HyperFlex data platform to work normally. Here you can see the IP addresses in management and data VLANs, and the vSwitches configured on the hosts. We have all these hosts, but if we take a look at the storage, we only see the SpringPath data stores, which are the housekeeping drives and not a part of the shared data platform. They are only carrying the HyperFlex specific information. We cannot yet deploy a VM on the HyperFlex data platform because no data stores have yet been created in HX Connect. These data stores will show up as NFS shares in the list of the data stores when they are created. This is done in HX Connect under Data Stores tab, and currently cannot be done in the vCenter. So let's create a HyperFlex data store. We will call it HX Data Store, and we will provision 1 terabyte of storage to it. As you can see, the new data store is shown as mounted. This is because it is now mounted on all the hosts in vCenter, and it is in normal operation status. If we return to vCenter and check the data store list again, we can see that the HX data store is now listed in the data store list. So all the ESXi hypervisors now have the access to the HX data store. We can now use this data store for normal vSphere-based operations. I have uploaded a CentOS virtual machine template, which we will deploy on our data store. We will name it CentOS 1, and we can now provision it on a vSphere cluster as in non-HyperFlex vSphere deployment. We will deploy it on node 4. And since node 4 has our HX data store mounted, it is listed as available for deployment. This other data store is the host local housekeeping drive that is only visible on the chosen host. Now we have provisioned a VM on the system using the HyperFlex data store, the same as in any vSphere deployment. The new VM is now running on the ESXi hypervisor of the chosen host. If we take a look in the HX Connect, in the Virtual Machine tab, you can see the CentOS VM is now visible in the HyperFlex management interface. From here, we can power on the machine, and the machine will be powered on in the vCenter. We can now connect to the VM and start using it. At some point, we might want to snapshot the VM we have created. The HyperFlex data platform offers a very efficient file system level snapshotting, which we can do from vCenter directly. The HX installer has installed a HyperFlex plugin in the vCenter to make native HyperFlex operations accessible from here. The native snapshot interface is integrated with the existing vSphere snapshotting and can be managed from the same interface with the same functionalities as the regular snapshots. Here you can see a Sentinel snapshot. For the HyperFlex native snapshots to work, the initial snapshot must always be a HyperFlex snapshot and should not be deleted. This is also mentioned in the snapshot description. You can also schedule the HyperFlex native snapshots the same as standard vSphere snapshots. The snapshots will be then created automatically based on the choices you make here. Ready clones are another HyperFlex native functionality that is integrated into vCenter through the HyperFlex plugin. The HyperFlex native cloning process utilizes the log structure of the file system to create clones very efficiently, just by referencing the existing blocks of the original VM that we are cloning. The result is an extremely quick cloning process. You can also create VM clones from the HX Connect interface. Here we see the template and the VM we provisioned from that template. We will create 10 clones named the same as the original. And since we already have clone 1, we will start provisioning at 2 and increment the number by 1. The preview shows the names of the future clones. If we check the load on the system during cloning, you can see there is no spike because of the cloning process. If we return to the VM tab, we can see the clones have been created. These clones are also instantly visible and manageable from the vCenter. The clones have been distributed across the nodes of the cluster, and we can move them around at will. There is no background process running that is still provisioning the VMs. You can see the actions we take in HX Connect are logged and are visible in both the vCenter and the HX Connect under the Events tab. The deduplication, compression, and distributed nature of the HyperFlex data platform also takes care of the space utilization across nodes. We can get information about hardware performance from vSphere, as well as from the HX Connect. In this way, you can quickly determine potential problems with the system and respond to the situation. We can also initiate HyperFlex maintenance mode from both systems. Since every converged node in the HyperFlex cluster also serves as the data platform through the CVM, normal vSphere maintenance mode is not sufficient on HyperFlex hosts. You should always use HX maintenance mode on converged nodes. The entire management of Cisco HyperFlex vSphere deployment is effectively managed through these two interfaces, while providing all the benefits of performance, scalability, and resilience in the background. General operations therefore feel very familiar and allow you to start using the HyperFlex system quickly and efficiently. This was regular cluster operations. Thank you for watching.